simple equation. Like this. If I have to ask you to solve this two-step equation, if I give you this equation to solve for x, the first thing you do is you would write it down. You agree?
Yes.
After you do that, you go through the process by which of solving. Well, what would be the first thing that you would do here? Yes? You're adding 1 to both sides of the equation. When you add something to both sides of an equation, remember, you're keeping it balanced. What you're doing to one side, you're doing to the other, because numbers are jealous. If this one gets 1, the other one has to get 1. It's like having children. This one gets, I want a cheese stick. Go get a cheese stick. The other one, I want a cheese stick. Go get a cheese stick. Same idea. Now, after you did this, what would you do? Well, hold on. Before you even get there, what would you do? You'd rewrite it, correct? And now what would you do? On both sides, the equal sign again, right? And then what would you have? And then you would be done. In essence, most of you guys don't have a problem solving that style of an equation. It's rather easy for you. It just takes a couple of steps. Most of you guys even go through and skip some things. What we're going to do is we're going to take equations just like this, and we're going to put,
That was good.
didn't mean to do that. Nope. Just want to move it down. That's all I wanted to do. There we go. What we're going to do is we're going to take something like that and turn it into what's called a 2-column proof that gives us what we did and why we did it. So I'm going to go back to this here in a second. Let me show you what this means. This is a 2-column proof. We'll use these pretty much for the next, I don't know, let's see, what month is October? Yeah, probably from mid-December we'll be working through a lot of proof stuff. Okay. Now, what we do though is we kind of take our time to develop them. We take our time to get used to them. I'm not going to lie, you guys are going to hate this, and I get it. But you have to believe me and trust me here that the way that I teach you guys and show you guys how to set these things up, you should be, in parentheses, successful at it. Because I try to take away all the guessing out of what to do, where to start. I try to give you guys the ability, the background to be able to figure out, okay, what the hell do I do first? I'm going to show you what the world to do first, because you'd be surprised that once you start it, it just flows right through. Okay? It's the idea of understanding what to do first. So what we work on are these things called 2-column proofs. One side is called statements, and the other one are the reasons. The statement side is basically, what are you doing? And the other side is why you did it. Now, when we start thinking about what you're doing versus why you did it, it gets back to the idea that every time you do something, you put it on paper, there's a reason why you wrote it down. When we start thinking about the idea of that problem I gave you, the first problem I gave you was 2x minus 1 is 7. Well, if we think about it in terms of the 2-column proof, and from now on, I'm never going to write statements and I'm never going to write reasons. I'm going to use S and R. It's too many words. Letters, whatever they're called. I don't understand them. We wrote that down. Why did we write that down?
That's what it wanted us.
It's what I gave you to do. So basically what I'm getting at here, guys, when you're told to do something, in a math problem or in a geometry style problem here in a little bit, your first step, 99.5% of the time, is to always write down what you are given. You were given something to do. You were given an equation to solve. Eventually we'll talk about, we'll be given specific parts about segments. We're going to prove something about segments. We'll prove something about angles. We'll prove something about triangles. But the first step lies within what were you given to start with? What information did you know? Well, if I go back here, the first bit of information I knew, the first thing I knew was this part was given to me. After that, we did a lot of math. Right, but what happens here is that since we're talking about specifics, we have to use rationale. We have to use real terms, real definitions, things like that that we were using. We have to use properties. And Lord knows you guys don't remember all your properties of algebra. You know how to use them, you just don't know what they're called. So, I have a handy-dandy chart. Within this handy-dandy chart is what we call your reason bank. These reason banks are basically all the possible reasons you can use for that right side of the column. You cannot make stuff up. If you make stuff up, you're automatically wrong because it wasn't on there. One of the things we use intermittent with this sheet as well as like next week when we come back from the long weekend, we'll start working on some more geometry style ones. And what we're going to do is not only talk about these algebra stuff, but we're going to talk about things in terms of what's called a progression. If you're given a midpoint, and I'm going to tell you exactly what you would write out if you were given a midpoint. So that way, if in a problem you were given a midpoint, you know what to do because these you don't have the chart I'm talking about yet. I'll give it to you next Tuesday. That will tell you specifically your next step. Now, as you can sit here and read this front page here, it talks about different math properties, algebraic properties of equality. What that means is that you're adding something to both sides of the equation. You're subtracting something to both sides of the equation. You're multiplying, you're dividing, things like that. Those things have equality to them. Now, I don't know, these seem long-winded. We know, what did we do on that second step here? What did we do here? So if we added 1 to both sides of an equal sign, let's do this. Let's talk about abbreviations. Let me pull this up here real quick. Because I want you guys to have this document that makes sense to you, and I'm going to show you ways that I'm going to allow you to abbreviate some of these. So you don't have to write out addition, property, equality. That's pain. But we can write add, prop, equal, couldn't we? Yeah. Things like that. I want to be able to abbreviate stuff. I want it to be easy on us. So if I look at these, we're just working on these today. Next to, bless you. There it goes. To the right of what this would look like, I want you guys to write down some of the abbreviations. Okay? If you want to write down addition, property, equality, go for it. That's too much. Let's write this. Add, prop, equal. It can't just be addition property. It has to be addition property equal because you added something to both sides of an equal sign. You kept it balanced. Does that make sense? Yeah. If I look at subtraction, the way that I would write that out would be this: sub t prop equal. I want you to put that t in there because we do subtraction, we also do substitution. So I want to make sure that we have the distinguish between the two. Okay. Everybody okay so far? And I know you guys all have done these before because we've all solved equations. We've done a bunch of equations in here, so I know you've done them. Sometimes not right, but you've tried. Okay. Mult property equal multiplication property. If you come up with some other shortcut of this, you're wrong. These are the only ones I'm accepting. You understand that?
Yeah.
Okay. Multiplication, I'm sorry, division. Division is the only one that I use the symbol. That's the only one I'll use the symbol for. The rest of them, it's the division symbol. Hi! Long time no see.
Yeah.
It's good to see you again.
See you. Nice.
What did you just... I didn't do anything. Okay. I'm sorry.
Wait, what are those two? Are those that? Is that an A and an A?
Is that an A
What?
or above
You've never seen the division symbol before?
Oh,
no.
I thought it was like A.
No, guys, it's just this.
No, Mr. Murphy, it was like kind of weird. It looked weird. I thought it was A. My bad. I thought it was a small A. What?
How did you see A?
Oh, I
It's
can't
like a small.
talk.
I'm on the back of the dang. Get off, Mr. Murphy.
I see it.
Yeah, I'm kind of blind, so.
I got astigmatism. I
I
thought that was an A. Wait, he said it looks like an A. Will you zoom in?
That looks like the at symbol.
How does that look like an A? Okay, do you see the line? Do you have astigmatism?
Uh-huh.
You sit in the back.
No, I wear glasses or contacts.
I don't have any glasses or contacts.
You might want to get some.
Let's just move on.
Yes. It says it's fun.
Okay. Yes, sir. Yeah. That's the symbol for division. You guys never saw that before, though? Yeah. I thought, isn't that the button on the calculator? Distributive property. Distributive property is when you're sending something into the parentheses. DIST prop. There is no equal for distributive property because you're only whenever you use distributive property, it's only on one side of the equal sign. You're not distributing to both sides. It's a scalar multiplied onto something. It looks like this, where you have, I don't know, 3 times the quantity, 2x minus 1 equals 18. Where in this case here, I would distribute to both of here, you get the 6x minus 3, and you go on from there. This is not an equal, this is just distributive property. That's it. Yes, sir? What the word equality means, whenever you're adding something to both sides of an equation, you're keeping it equal. When you multiply...
You said the equality of 2. You just said you was like 3, and then you said the equality of 2 and something like that.
No, I don't think I did.
Then you said 2 equality. You said
Quantity.
Quantity. Yeah.
Oh, 3 times the quantity.
Yeah.
That's when I say times the quantity, that means there's stuff inside the parentheses.
Right.
That's what the vocabulary means. We're not making fun of you. If we were making fun of you, you'd know we were making fun of you. And then lastly, substitution. A lot of times when we use the substitution property, I just usually write out substitute, like literally the whole word. Okay. I'll write out the whole word substitute. And there's a reason why we use substitution. You were asking about this when we were lined up vertically. There's a reason why we use substitution versus transitive property, which we'll talk about more again tomorrow. It's a very subtle difference, but those are the abbreviations that I like to use. That's really all the stuff I abbreviate. Now, as you go through the rest of this as we're looking on here, besides on our phone, you'll notice that there's other things like reflexive property, symmetric property, transitive property. All of these properties will come into play. They're not always gonna come into play within our algebra stuff that we're looking at today. We might need to use a little bit here and there when we do real geometry stuff. Of these properties here, the one that you'll use the most is the transitive property. The transitive property is the law of syllogism. So since we're writing down little shortcuts and stuff here, on the very bottom here where it says transitive property, on the very bottom where it says this transitive property, I would probably put on my sheet like a little example. Oops. I would probably put maybe right in here, if A equals B, B equals C, then A equals C. And I want you guys to do this. Circle that it's on a diagonal. The transitive property always has a diagonal component to it. It will always have some value across from another. Just like the law of syllogism had, where we repeated that last statement, it came first. That's what transitive property does. Whether you're dealing with numbers, segments, angles, anything. I just want you to have that right in front of you so that way when we're thinking about it later on, we'll have that example of knowing when it is. Okay? One of the other things that I will be creating with you guys starting next week is what I call a progression chart. These little squares are going to tell you what to do and when. And it's going to give you examples of every property that we talk about. What I'm getting at here, guys, is that you're going to have all the information basically on 2 sheets of paper in front of you at all times to do everything. Homework, quizzes, tests. I don't take these from you. I don't. You won't get it on the final. But the idea here is, are you resourceful to create this on your own, to never lose it, same thing with this, and use it every day? Because these pieces of paper become like, I don't know, gospel, I don't know. Golden tickets, yes. They're golden tickets. My kids just watched that the other day. That's a fun movie. It's a great movie. And,
What movie?
Charlie the Chocolate Factory. It's Willy Wonka and the Chocolate Factory. The OG version, not the scary Johnny Depp, Tim Burton dog version.
they're both out there. So what these things are going to allow you to do is eventually when we start talking, and I'm not lying, guys, geometry proofs are going to be tough. You're not going to like them. You're going to fight with me about it all the time. You're going to say, I don't get it. And I'm going to tell you each and every day, look at your sheet. What does it tell you to do? And it's going to tell you specifically what to do. Okay? Yes, sir. You'll see as we get in there. As you flip it over there, if you look at the back, here, you've got definitions. A lot of those definitions are what we're going to use for our progressions as we go on later next week. We're going to turn these definitions into these boxes. And it kind of becomes your own like little flip chart of what to do. It sounds really, really weird, but as you start to see them a couple times, it's not terrible. All right. So let me go back to the problem we were working on that we've already solved, and let me explain to you guys what are the reasons going to be as you fill them in. Well, the first reason was gave you a problem to do. So you wrote it down and you wrote given. The next part was we added 1 to both sides.
So would it be add prop equal?
Add prop equal. Now, there is 2 other things that are not on your sheet that we have to decide how to write. We need to figure out what's going to be the difference between simplifying and solving. Because do you guys agree at this step here, all I did was combine my like terms and I rewrote it? Really, anytime that you just rewrite something by simplifying or rewriting to combine like terms, all you're doing is this. You're simplifying. So the difference between simplify versus solve. I want you guys to use the simplified step whenever it's in the middle of the problem. Oops. Whoa. Whenever it's in the middle of the problem, or when you are rewriting, solved is when you're done. You got x equals blank. That's the only time you use solved. Right. That's it. That's the difference between the two. It's not on that reason bank. So maybe in the middle or towards the bottom of it, just right on there, on the bottom down here, simplify versus solve. Just put it in the bottom part. Yes, sir. Austin. Austin. There you go. Okay. So make sure you have the differences there. Yes. That way you write down the stuff that's on there so that we know the difference of when you're using it. Okay? Does that make sense? So back to here, we simplified. What was the next thing we did? What's that? Ah, we're here. So it's division, prop, equal. Yep. And then now we are solved. Every single step here has a reason. You can't just skip things. What these algebra proofs do, quite honestly, is it just forces you to do the math slower. It forces you not to skip a step. It's making you guys be very specific in the order in which you write things down. And it's making sure that you don't skip something. Yes, sir.
Wouldn't it have helped us for this year?
I don't know. I know that you guys talk about properties, but you never really had to give rationale for it, I don't think. We use this, usually we wait, and this is a really good question. We usually wait to talk about rationale for the algebra until right now, because by now, 2, 3, 4-step equations shouldn't be terrible. You guys have been working on those for the past 4 or 5 years, if you think about it. What this is doing is it's taking you that one step further. It's taking you from the algebra part to the geometry part. And the geometry part of this problem, of what we're looking at now, really is just this. It's just that. That's the geometry right now. Putting it as what we call a proof. Showing your work is algebraic. It's like algebra proof-ish. But the geometry, it's making you write down why you did it. That's why we do it now. We're taking something that was not terrible, and we're adding to it. That's what happens a lot of times in math. You start with the basics, and you just build and build, and then all of a sudden, wham, the hard stuff hits. But it all built off of something simple that you've already mastered, or should have. Okay? Let's try another one. This didn't work as cleanly as I hoped. Put this back on the clean one. So, here's our equation. Two x plus 5 equals 20 minus 3x. What do you think your first reason is? Given. It's going to be given. Is there any one right way to always solve an equation? Or are there multiple ways to solve equations? There are. Some people do one thing, some people do something else. And what's nice about proof, normally you can get through and prove something even if you went a different direction. As long as your logic behind it matches up to what you're doing, you're going to be fine. In this case, I grew up and I try to teach you guys to start with the variables and pick on the little guy. So what would I do?
At minus 2.
I'd add 3x.
Oh.
I would pick on the little guy because if I subtract 2x, I wouldn't be wrong, but then I got to deal with negatives. There's nothing wrong with that. It'll work. But knowing in my head, knowing how you guys are sometimes, you tend to screw up when you have the negative. So I'm going to add 3x to both sides of an equal sign, which means if I'm adding on both sides of an equal sign, what's my reason? Add prop equal. You have to have that equal in there because you did it to both sides. What's my next step? Simplify. Very good. I simplify by just combining my like terms. Yes, ma'am. Yes, absolutely. Yeah, you guys can simplify more than once. There's no set for a lot of these things. There's really no set number of steps. Sometimes people will start a problem up and then realize, oh, I screwed up, and they just keep working on it, and they wind up with a lot more than they need to. I think as we get into our geometry style proofs, I try not to make you guys have more than 6 steps a lot of times for what we work on. As we get further along into triangles, some of those might turn into 8 or 9 steps because at the very end of stuff, there are a couple little things you can always say, and that's what we do at the tail end after proving something. But it's not going to be crazy. Remind me tomorrow. I left myself a note on my phone to bring in my old calculus notes from college because we did proofs in college. Well, in math, upper level math is all proof. It's awful. And I'll show you guys. I'll scan one of them and I'll put it up on the board to show you what the proofs are. Yes, sir.
You don't burn your notebooks after you're done with them?
No.
Oh,
Why would you keep it?
I do.
Because I have a degree in it, and since I use math a lot, it's nice to have if I ever want it. Who knows, what happens if I teach calculus at some point in time and I need extra work?
But math changes.
Does math really change? Is
No.
2 plus 3 still 5?
It should change. I feel like it's too different right now. It needs to change.
Math is like,
Math hasn't changed in
I
thousands of
think
years.
the way it's taught.
I mean, it has. The way things are taught, things like that have changed. But well, back to this one. What's my next step?
The next step is subtract 5.
Okay, good.
So it's sub T prop equals
Sub.
prop equals.
Okay, now what?
5 is simplified. Again, because you're basically just.
Yep. I just rewrote. So my reason was.
And then 5, you divide by, I mean for 6, you divide by 5.
Bless you. I divided 5 on both sides, which means I write.
Divide prop and 7 is x equals 3. 7 is solved.
Okay. I want you guys to make sure that you don't just go from here and write x equals 3, because you technically skipped what you did. See what I'm saying? You got to, because you're right, it is going to be 3, but how did you get there? You don't want to just jump the conclusion. You guys, have you guys seen Office Space?
Yeah.
Jump to conclusions, the math you wanted to do. You don't want to jump to conclusion. If you haven't seen it, watch it over the weekend. You'll love it. It's great. Office Space.
Mike Judge is great overall.
Have you seen my All right, I want you guys to do this one on your own.
Did you need King of the Hill?
Yeah.
Do you have homework to do?
Of course.
I'm going to pass this.
Hey, I'll even help you out. I'll give you your first reason.
It's Kevin. Oh my God.
Wow.
You're welcome. Merry Christmas. Take a couple minutes and remember, all you're doing is solving an algebra problem, but you're writing down what in the world you're doing. That's it. Yes, ma'am. Yeah, that's fine. Now, did any of you guys divide by -4 right away?
No.
Could you have?
Yes.
Yeah, that's one of the things you could have done. Now, most of you guys did this, and you probably went and just used distributive property. So right away, you rewrote the thing as -44x minus 8 is 80. And the reason that you did that was the distributive property. Now, hopefully you didn't write equal after dist property. Good. Because you did not distribute anything to both sides of the equal sign. It's only on one side, so it's not over equality. I go to the next step. I'm guessing most of you guys did this. You added 8.
How'd you know?
You add 8 to both sides, then you have add prop. Okay. And now you rewrote it. Whenever you rewrite, you're simplifying. Very good. And then lastly, well, next we do divide by the -44. Divide prop equal. Good, good, good. And then you have a solved at. And that's what we're working on. Yes, sir.
Like, if this problem was like 80, it would be like equal 80, quality of like some numbers.
Yeah.
Would you then pick the strip probably equals?
No, because you're just distributing on one side, and it could be a different number on the other. You're not distributing the 4 to everything. It's just to one side. Okay. If it was like a 2 times 80, then you'd have to distribute the 2 to the 80. What I have for you guys to work on tonight, I have 5 of these. This is section 2.5. I think it's page 109, and I forgot the numbers.
No, obviously I did not.
All right, calendar. Yeah, it's page 109, 6 through 14 evens. It's only 5 problems. I want you to do the 2-column proofs. Six, 14, excuse me. Okay? You got 5 of them, okay? It should not be an overbearing, crazy problem to set up. Hey guys, the algebra should be really straightforward. There's nothing crazy here. What we'll do then tomorrow is make sure that we got this stuff buttoned down. Then we're going to go back over what's left over, anything left over in 2 that we haven't talked about, which I think we've covered everything. I'll have some review stuff for us for then on Thursday. What's that? The bell's going to ring in a minute. Oh, with lockdowns? That crazy lockdowns.
I love his hair.
That's great.
It's like,
As long as he's at the door, the rest of
Yes, ma'am.
I like adding.
I'm going to bring